Hey guys, it's finally time for me to tackle the second Iron Scripter prequel challenge. Um, Definitely still playing catch up here as the fourth puzzle's out already and the fifth one will be out over the weekend, so I've got a little bit of ground to make up there. So as with the last challenge, we've been given some code here to work with, and it very much looks like an old VB script that somebody has converted over to PowerShell effectively line by line. It's definitely not the quote-unquote right way to be doing things in PowerShell. So part of this challenge is going to be doing things the PowerShell way. But let's have a quick read through to find out exactly what's wanted from us. Um, Obviously, same as last time, I'll be representing the flawless faction. Um, So what we're trying to do is obviously follow our faction's aims. Best practice, we want to output a single type of named object, and we can assign the name ourselves. We want to calculate the percentage used for each disk. So if we look up here, this script is grabbing some information about the computer itself, and then it's going through and listing information for every disk on the system. So that being the drive, what type of drive, how big it is, how much free space it has. One thing not shown there is the used space, which would be the size minus the free space, which it's asking us there to calculate the percentage of used space, then create a format file or type file, and this is to control the display of the object that we're outputting, work with remote machines, and I'll be targeting PowerShell 5.1. So I'll be taking a slightly different approach to some of these things. With the calculate percentage used, I'll be using one of my other projects called Posh Percent Bar, which is used to display graphical representations of percentages. So instead of just showing 80% used, we'll show a graph of some description. And also, instead of using a format file or a type file, I'll be using default property setter, which effectively sets the default properties that will be displayed when you output an object. So a little bit of housekeeping first. I will increment this module, and so as a refresher, this module is what all of my code for the Iron Scripter challenge is going to end up residing within, so it'll be a complete package. So I'll increment this to version 2, and we'll start a little addition to the release notes down here, which I hopefully will remember to keep up to date this time. And I mentioned those two modules of mine that I'll be using. Now I do need to make sure that they are specified within the PSD1 file here, so that if you try and install this module, say theoretically if it was ever uploaded to the PowerShell gallery, you would also download those modules that are going to end up being required to run these functions. So we can do that by adding required modules, and specifying them here. So that's posh percent bar and default property setter. And let's just wrap those in single quotes and we're done. And don't worry about the specifics of how to use either of these modules yet. I'll cover them in more detail when we get to that. So given that this the code we've been given is dealing with disks, my previous solution I called get monitor information. This time I'll call it get disk information, and we'll start by defining a function. And to start, I'm going to grab the code out of the PDF and just dump it in as is. And let's quickly format that. So I guess we should start by just running this and seeing the output. So if we go ahead and run this, you'll see the output here is, well, it's just text. It's not outputting an object as such, and we see various information about my computer, the disks I've got, including a CD-ROM for some reason, and my 2 local disks. So the first thing I want to do here is get rid of all this right host nonsense and start working with actual objects. Luckily, to transition to that is going to be fairly simple. We can just use these objects that are already being created here, and instead of writing it out like this, just select the data we want from them. So I cut out doing the operating system there, just because it was a lot of unnecessary typing. But I'll quickly run through and do the disk as well. Now, this layout isn't going to remain like this. I'm just writing it out for the sake of completeness, but also I'm doing it like this so it fits on the narrow screen that I'm working with. So now if we run this, we should see some slightly different output, or rather dramatically different output. But what you'll see is that this is 4 total objects of 2 different types. And what the challenge asked us for is 1 object per disk of 1 type. So we should end up with 3 objects all of the same type on my computer. On other computers you would get a different amount based on the disks that are there. So I'll start by doing a new for each loop. And in this for each loop we'll be defining a new PS custom object. So I've just pulled up the code again on my other screen to make sure I don't miss anything as we go down. But let's start going down the list. And populating our object. So we start with operating system name. This one was an amalgamation of 2 properties, which looked a little something like this. So that is it for our operating system information, which means we no longer need that. And also, while we're in here, this is a touch long. So let's go ahead and change that to OS. Now we've got our disks, and for that we have just save a little bit of typing. Now, I'm not 100% set on any of these names yet. For instance, description is probably a bad name for that. In fact, what I'm going to do is call it disk description, just to make it a bit more clear what it's referring to. So that gets rid of our need for those disks there. So now if we run this, you'll see 3 objects. They do repeat the operating system information every time, obviously, but the end result, given that we'll be filtering out some of this stuff, won't have all of it there on screen, but it will be available to the end user if they need it. The other thing is this OS name probably isn't what the intended output was. So let's see if there's anything a bit better inside this that we can pull from. So having a look down, in fact it's just jumped out at me that I think caption is probably a good one. As you can see, I'm using Windows 10 Enterprise. Yep, let's use caption. Was there anything else about this output that doesn't look quite right? Well, I mean, everything there looks right. What you will notice is all of the sizes in the format of bytes. So they're not very readable, and we can probably convert those to gigabytes or provide the output as gigabytes. Leaving that there in case somebody does happen to want it in the future. Also, given these all mention memory, I sort of want to put these as being specifically disk size and disk free space, just to avoid any confusion. And like I did last time, at this point I'm going to switch over from get WMI object to get sim instance. Just because it's the more modern command, and yeah. Also, query should still work. And it does. But we can make that look a bit nicer by going with class name. Let's just double check that all still works. Cool. So we've got our first pass of the single object coming out. But one of the things we were asked to do is have a named object. So what that means is if we look at the output of this command and pipe it to getMember and turn off caps lock, you'll see the name of the type name of this object is just PS custom object, and that's because it is a PS custom object. We can, however, specify a particular type name, our own type name, and we can literally do that just by passing it as one of our entries in this hash table. So the keyword here is PS type name, and let's call this disk info. Now if we have a look at getMember, you'll see the type name is disk info. So where this is useful is without going into doing a complete class or something like that, you could use this as the type name you expect to pipe into another function, and you could also tell this function that its output type is disk info. So it just helps with predictable pipeline interactions between your functions or other people that are extending your functions. So we've done the type name. Let's double check the puzzle or the challenge to find out, to remind myself what else we had to do. So we're outputting a single named object. We need to calculate the percentage used disk space. So I mentioned I'd be using my posh %bar function or module for this. And what we'll do is go down here and say usage. So I've already got this installed, so I can call new %bar, and my percentage should be, now I'm not sure if I can do this in line, so bear with me. So let's just check that that actually works, because I have a sneaking suspicion that that'll have to be done outside of the hash table. But no, it doesn't. Excellent. Now, what we'll find is actually we might need to do it outside of the table, just in case we have something like a CD-ROM drive which doesn't have a size. So let's just take this and pop it up top. So let's just check that it's not null. If it isn't null, let's go ahead and calculate that. Otherwise, it's an empty string. So then down here, actually, let's create the %bar up top so that if there's a percentage, it'll render the graphic. If there's not, it's an empty string. There. So let's quickly run this again and see what we get. So empty string for my CD-ROM and graphic for those two disks. The other thing I mentioned I wanted to do was calculate the size of everything in gigabytes. So let's quickly do that. And I'm going to do this for both the disks and the memory. And I'm simply going to create new entries here, but with GB on the end. And I'm just going to do that for all of them. Right, so this is a pretty handy thing you can do in PowerShell, which is literally just divide by the unit of measure you're looking for, so gigabyte in this case. And we'll just repeat that for all of them. Now this is only the first step, because one thing that's going to happen here is we'll end up with some long decimal places. So we'll have to deal with those in a sec, but I do want to show you what this looks like without rounding. So let's have a look at the mess we've got now. So as you can see, this disk is 232 and some odd gigabytes, and it's got 178 free, but it's also got a huge amount of decimal places. Now 232 gigabytes probably isn't enough for precision, but 2 decimal places is probably plenty. So if we just go through and do some quick rounding, and we'll round that to 2 decimal places. And we'll need to do that for all of them. That one, that one, that one, and that one. And 2 decimal places. So let's have a look at that again. And now you can see that's a lot tidier. Although, what I failed to remember there is our disk size is in bytes. These virtual memory and physical memory properties are in kilobytes. So they're a full 1000 out from what I expected to get. So this could look a little strange, but what I'm going to do is, instead of fudging this and dividing by a lower unit, I'm going to instead multiply this out to bytes, and hope it works. So, fingers crossed. That is looking a lot better. So I've got 7.89 free physical memory, which looks about right to me. Perfect. Now, the puzzle asked for a format file or type file, and that was to, sorry, my syntax highlighter looks like it's just taking a bit of time to sort itself out. So it asked for a format file or type file. Instead of doing that, I'm going to use a default display property set, which is a mouthful, but it'll give us the same result. So first things first is we're using a hash table here, and by its very nature, a hash table could end up in any order. So we've got OS name first, compressed last. It is possible for the output here to come out in an order we didn't expect. We can control that by using ordered, which tells PowerShell to create a ordered dictionary, and that will mean that this always comes out in the correct order. So that's part of controlling the output here. The second part is determining which 4 values we want to see when we run this command. And the reason I'm saying 4 is because if we have 4 properties displayed to the screen, instead of seeing a list like this, PowerShell will do a nicely formatted table for us without us having to do any work at all. So before that, I'm going to add, just thinking ahead to when this can be run on multiple machines, I'm going to add a computer name in here, which for now will just be computer name, and my default output will be the computer name, the free physical memory, the size of the disk in gigabytes, and the usage. So that will show us the basic and most readily useful information, but using a select statement, which I've gotten rid of from above, using a select statement, all the other information is still available to us. So let's have a look at how to do that. We'll start by storing each of these objects in a variable. And then we're going to apply our default property set to the object. So using my default property setter module, we've got access to a command called set default property set. We can give it an object, which is our disk object above, and we can tell it the display set. In here we need the properties that we had identified as the ones we want, which is our computer name and save typing, free physical memory GB. Actually, no, I don't want free physical memory GB. What I'm going to do instead is put in device ID. And I'll explain why in a moment. But I do want the disk size in gigabytes, and I want the usage. So the reason why, thinking through it then, that I wanted device ID rather than memory is when this is running and all I see is these 4 properties, if I saw the computer name, the disk size and the usage, and the memory, I wouldn't know which disk these are applying to, which makes this not all that useful. So, tangent aside, we've set our display set on the object. Now we need to return the object. And let's have a look at the result. As you can see, nice little table. However, as I said, the other information is still there behind the scenes. So if we were to select all, we've got everything there. If we wanted to see the device ID, disk size and disk free space, all of that's still there. So the information's all there. All the default display property set's doing is saying to PowerShell, by default, just show me these 4 things, and because it's only showing 4 things, it's going to do it in a table. So I alluded to it before when I added computer name, but this is going to have to target remote machines, and we're going to do that through a parameter. So let's start building this thing out. We've got our commandlet binding, and we've got parameters. So our computer name is supplied as a string. We'll call it computer name, and we're going to default this to the local computer name that the function is running on. So instead of this being computer name down here, or that computer name, it'll change to this variable. And also we need to tell these 2 get some instances that it could be looking at another machine now. Excellent. So before we get into anything else, let's double check that still works. Cool. And just to demonstrate some things that are going to crop up in a second, let's give it some computer names like doesn't exist. We get some errors, which given we're the flawless faction we're going to have to deal with. And let's give it another machine on my network that doesn't currently have WinRM turned on. Cool. So these, if you watch my last episode or my last video, are going to be very familiar, where it's basically how we're addressing these is going to be a carbon copy. So I'm not going to spend too much time explaining what we're doing to handle these errors. If you're interested, go and watch the other video. It'll be in the playlist. But first thing is, in fact, let's get the previous one open. So you'll notice there's a validate computer private function in there, and we're going to use that exact same thing for this. So let's whack that in. And so what that's going to do is it'll ping the machine that we've supplied via computer name, and if it doesn't exist, it'll let you know that it doesn't exist. As an example, let's go back to our doesn't exist, and it says, well, actually, this error is a little bit different because this isn't loaded into memory, so that doesn't help at all. Let's try that again. So we do doesn't exist, it should go off and ping it. If the computer doesn't exist, it's either offline, doesn't exist. Please check the values correct and run it again. Also, to speed things up, I'm going to borrow my error handling from the previous challenge as well, given that it's the exact same thing. And I'll be taking the opportunity to use the write verbose messages at the same time. So let's grab all that, pop this in a try. So this time we're grabbing Win32. And it's the same thing for the disks. This one here being logical disk, not operating system. So last time I wasn't able to write everything to the debug stream, but I'm willing to give it a go this time. Basically see if it works or not, and if it doesn't, we'll deal with it. So that's OS, that's disks. Alright, so let's not get too far ahead of ourselves without double checking that everything still works. Let's run it on our local machine. So I had two issues there. The first one being that my VS Code session had got a little bit muddled up, and the second one being that I basically needed to dump each individual disk into the debug stream at a time rather than trying to do all of them. So that's working now. I think the last thing I'm going to do here is, much like I did with the previous challenge, is just do a generic catch statement for everything else. Just making sure it's on the right line there, which it isn't. That looks better. So this has failed to get disk information from computer, and And that looks like a lot of error handling, verbose output, debug output. I think I might need a little bit more. Yep, I can output the disk object to the debug stream as well. I could potentially put in some more verbose output, but I think that more or less gets the point across. So let's run this again and make sure we're getting everything we expect to see. So get disk information is working. If we look at a computer that doesn't exist, it goes off to ping it and we get told that it doesn't exist. If we give it a computer name that does exist, but WinRM isn't configured, except that I've forgotten one thing. Try blocks only trap terminating errors, and by default get some instance isn't going to generate a terminating error. And we can change that by changing the error action to stop. And that will generate a terminating error. And the other thing to check is our verbose output. So we get a lot of nice information there. And finally is our debug output. So as it does with the debug stuff, we get the output and are asked to continue. So we're seeing each disk there. Then we're seeing the object for that disk. And finally, we should see the pipeline output. And if we keep going through, we see another disk, and that's the end. So there we go. There's our complete solution for the second Iron PowerShell puzzle, Iron Scripter PowerShell puzzle. And all in all, I quite like the look of that. We've got a lot of information packed into that object, but we're only seeing what we need to see. And personally, I'm a fan of this particular style of showing the percentage used on a disk, hence why I use that module quite a bit. On that note, if you do want to have a look at either of the modules that I've used in this puzzle or solution, or you want to see the solution itself, all of those links will be in the description. And if you want to leave a comment or reach out to me on Twitter, go ahead. I'll very much appreciate any and all comments and feedback and or conversations in general. And hopefully I'll be on to the third puzzle soon and eventually be all caught up and not be a few weeks behind. I'll catch you next time.